Hey everyone, welcome to this video lesson. So we're going to pause on solving quadratic equations for now. Okay, so this lesson, you will need to be able to understand the concepts in this lesson to be able to continue solving quadratic equations. So you're going to learn how to simplify radicals, and I'm going to do this in one video, meaning I'm going to do the first half will be one video, and then the second half will be for imaginary roots notes. So you'll be introduced to finally imaginary numbers, okay, which later you'll see them as complex numbers. So before I go into the lesson, let's just review. So if it's a quadratic, it should have two solutions. So it's possible that you have two real roots, okay, meaning the graph crosses the x-axis at two different points or two different locations. It's also possible that you have just one root, meaning the graph only touches the x-axis and then bounces off of it. So in this case, we call this a double solution. But it's also possible that the graph doesn't cross or touch the x-axis at all. So in that case, this is when you have imaginary roots. So before I go into review what you already know when it comes to radicals, okay, these are perfect squares. So 1, 4, 9, 16, 25, 36, 49, 64, and 81, and the list continues. It's an infinite list because when you take the square root of any of these numbers, you get a whole number. So for example, square root of 1 is 1, square root of 4 is 2, square root of 3 is 9, and so on and so forth. Okay, so then with that said, let's review what you've already seen, either in geometry or algebra 1 or even before those two courses. So this is why the square root of 9 is equal to 3, because when you do a prime factorization tree, okay, you end up with 2 3s. Since we have two of the same prime number, that means we can take one out, and notice there's nothing left. So then the square root of 9 is equal to 3. So I'm using prime factorization tree here. So for example, prime numbers that you multiply together that give you 12 are 3 times 4, but 4 is not prime because 4 is 2 times 2. So notice we have 2 2's, so that means we can take a 2 out. So then when we take that 2, the 3 cannot come out because that 3, there's only one of them. So let's leave that 3 inside of the radical. So that's the simplest radical form. Next example. For this one here, multiples of 45, I'm going to say 9 and 5, right? But you could also do 3 times 15, and then 9 is not prime because 9 is 3 times 3, which is what we did here. And then we have that 5 left. So since we have 2 3's, we can take a 3 out. So then this simplifies as 3 square root of 5, because the 5 we only have one of them. Okay, you gotta have 2 to be able to take one out. All right, so then the next example. Oh, and there's something I forgot here. That 2 should be there. So let me go back and change this. That's my first mistake on this video. So we need to multiply 2 times 3. Okay, so then that means when you multiply 2 times 3, that gives you 6. This something happens. This happens to me sometimes. I get carried away. So 6 square root of 5. Now this is the final answer for that problem. Okay, so I hope I didn't confuse you here. You got to multiply this 2 times whatever comes out of the radical, which in this case was 3. Right, next example. We have the negative there. So I'm not going to lose that negative on this one. 75, we can do 3 times 25. But then 25 we know is the same as 5 times 5 because 25 is not prime. So now we only have prime numbers as factors of 75. So then we have a 5 coming out, but don't forget that negative. Okay, I'm going to keep that negative, so I'm not going to make the same mistake as in the previous example. And this is the simplest radical form of number 4. For number 5, this is, you can actually do this one in different ways, but I'm going to do this as 54 times 10, and 54 is the same as 2 times 5, and I'm sorry, 10 is the same as 2 times 5, and 54, we can do 54 in different ways. So let's see, so let's say 27 times 2, okay, and 27 is the same as 9 times 3, and 9 is the same as 3 times 3. So then we have 3 3's, and then we have 2 2's, and we have 1 5. Okay, so notice we can take out a 3. We can also take out a 2. Okay, so then I'm going to write that here for the sake of space. So we have a 3 coming out because of that 3. And then we have a 2 coming out. And then we have the square root of, multiplied together 3 times 5, which is 15. Okay, so then we have 3 times 2 is 6, square root of 15, and this is the simplest radical form for number 5. So again, the key is to get prime factorization done, and then see if you can find two numbers that are the same or two prime numbers that are the same, so you can take one out. So for each pair, you can take one out, and then simplify as much as possible. All right, thank you for watching this part. I'll do the second part on the other video. Okay, bye-bye.